Thanksgiving does not count. It's not
It's
called
not
Thanksgiving.
It is a Thanksgiving, but just with friends.
On the notes, we're going to go through these notes. We're probably going to go fairly quickly. Then we're going to go back over the stuff that we covered before break with the parallel lines. And then probably, I don't know, we'll see how I feel once we get to that point. We might work some of the packet together, might just say, do it yourself quietly and Ebersole, relax for a few minutes.
Didn't you have all week on last week to do that?
Wait, can we put our desk together and work on it like that way?
Maybe. On this, given, forget that we even have this fill-in stuff here, just follow along, fill this stuff in. I believe these are the 2-column proofs that came from your test. All right, so what's the given information tell us?
CE is congruent to FE.
So on your paper, mark those two as congruent, put the little tick marks on them. What else they tell you?
ED is congruent to EG.
Can I mark them same way?
No.
What tick mark?
2 more.
2, yeah.
All right, so put 2 marks on them. Now, just looking at that, if I know this has 1, this has 2, this has 1, this has 2, what do I know about this whole thing, that whole thing?
It's congruent. It's all congruent. Oh, you menace to surprise.
So the 2 whole things have to be congruent, and that's what we're trying to say. As soon as you see a picture, it looks like this again. See a picture, it looks like this again. What should you think of?
There's 2 lines.
If I give you a picture, it looks like this. Ignore that. Segment addition postulate. So somewhere in here, we're probably going to use segment addition postulate. And this is where you guys get yourselves in trouble, because anytime they have one that's just a fill-in one like this, you want to start right away and just fill it in and not think it through. Right? But if we think it through, we know these 2 are the same, these 2 are the same, these 2 are the same. Well, if we add these 2 together and we add these 2 together, what should be true about our 2 answers? They should be the same. So looking down through here, how did we know this first statement?
It was given.
That was given. My pen doesn't write real well on this, so just have to bear along with it. What'd they do to go from 1 to 2?
They made it in algebra form.
All right, so they changed it from geometry form to algebra form, and what is that?
I forget.
Definition of congruency. Again, this is going to make a lot of these stray marks like this as I go through and write on this, because it's a picture. So just bear with it. What'd they do on this one? Segment CE plus segment ED equals segment CD.
Substitution property. No, wait.
Segment addition.
Segment addition postulate. They added this segment plus this segment to get the whole thing. Segment addition postulate.
Same thing for the next one.
I don't know, let's look at this next one. Segment FE plus segment EG, so this segment plus this segment equals segment, that's not what this says. This says CD, it says it equals this whole
So
thing.
they're congruent.
That's substitution.
What did they use there?
Substitution.
Look at what we have right here. What they did, and I wouldn't mind if these were in a different order. I'd probably put it, if I was doing it, I'd probably put it in a different order. But what they did is they took number 3, and right here where you see CE, what'd they stick in its place? They stuck FE in its place, didn't they? And that's what we got right here. Then where you see ED, right here, what they stick in its place? EG. Alright, so there, what did we use? Substitution property. Now, looking at number 5, segment FE plus segment EG. FE, that's right here, plus segment EG, which is right here. That one we use segment addition postulate on. Again, this is part of the reason I don't like the fill-in ones, because that's not the way I would have thought of it. I would put the two segment addition postulate ones together and then did the substitution. Now looking at what they have in 4 and 5. Anybody see anything in 4 and 5 that catches your eye?
You're adding the same.
Yeah, adding the same thing, but you get a different.
They're both the same thing on this side, aren't they? So if segment FE plus segment EG equals CD, and it equals FG, what should be true about these two? They should be congruent, or they should be not congruent yet, but equal. They should be equal to each other. What do we use there? Took out one thing and stuck something else in its place. Then to go from 6 to 7, what did we do? Just change from algebra form into geometry form. Doing algebra. Everybody got all that one?
Yeah.
Next one. On the algebra 2-column proofs. These we can probably just go ahead and make our 2 columns. What's our first column?
Statements.
Statement. Second column.
Teachers, pardon the interruption with those students going on the field trip with Ms. Terrell. Please report to the office. Thank you.
What's our first statement gonna be?
The given.
So
2 order column.
2 parentheses 3x minus 5.
How do we know that? What are we gonna do next to start to solve this?
Distributive property.
6x minus 10 is -4. And then you put distributive property.
That's from mine.
What are we gonna do next?
You're gonna do
Plus 10. on the
Add 10 to
side.
both sides. Again, in our 2-column proof, do we want to show our work?
no.
No.
They just go 3x.
Be careful.
equals 6.
What is it?
6x equals 6.
6x equals 6. Everybody agree with that?
Yep.
What did we use there?
Addition, property, equality.
Addition, property, don't forget the of, equality, because we did it to both sides. Did the same thing to both sides of the equation.
4 is x
4 is what?
X equals 1.
Does everybody agree with that?
Yeah, that was division of equality.
Again, don't make these 2-column proofs harder than they are. Even if you don't completely understand them, you should be able to get a whole lot of the points if you at least try.
I get these ones with the elements. I don't know what, but
The angle ones? The
Yeah.
angle ones are the same.
I don't know why. I just can't get that memory.
Do we even do any angle ones yet?
Did some manuals. As a matter of fact, I think the next one's.
Are you checking our homework or no?
Why would you say that?
You are
Yeah,
such a
okay.
terrible
That one.
person.
Oh no, this one's a segment problem.
The next one's.
The
an
next
angle.
one's an angle.
I mean, I could do my.
First thing, what do we know?
PQ is congruent to RS.
That's what we know?
No.
Q is the midpoint of segment PRs.
So if Q's a midpoint of segment PR, what's that tell us?
They're
PQ,
congruent.
QR.
What's congruent?
P, Q, and Q are.
So mark them on your paper there.
And then R is the midpoint of QS.
So if R is the midpoint of this segment, QS,
Then
what's that tell us?
RS is congruent to the.
You are.
So RS is congruent to QR, well then what's that tell us about all three of these?
That
They're
they're all
congruent.
congruent.
So let's just put one tick mark on each one. Can you always do that? Just put the same tick marks on all of them?
No.
No, this one it is, what'd they ask us to find? Or
PQ
prove?
and RS. We already did.
So we should be able to go through our 2-column proofs here and do it, right? First column again,
Statements and reasons.
what's our first statement gonna be?
PQ.
No, Q is the midpoint of PR.
Segment PR, right? How do we know Q was the midpoint of segment PR?
Given.
And then you can say that PQ and QR are congruent.
As Soon as you see that you have a midpoint, use that. Once you know it's a midpoint, what's that tell you? What'd that tell us?
P, Q, and Q are.
Do we have to switch this into algebra form?
I don't know, we'll decide that here in just one second. How do we know that those two segments were congruent? What told you that those two segments were congruent?
That's given.
Midpoint.
It was a midpoint, and we have it written over here.
Midpoint splits segment into two congruent segments.
That's what you write down. Midpoint splits segment into two congruent segments. Oh, we should take that definitions test today, though. I forgot the other day.
Wait, you
No,
forgot
no,
about
it's
something
laying right there, yeah.
Oh man, I'm gonna.
That's unlucky.
That's unfortunate.
So
Why did you say
we'll
that?
see how you guys do after we get this done, if you work really hard. Francine, think they'll work really hard?
I think I'll work really, really,
Think we'll be
really hard
taking the
if we
test
don't do
probably.
that test. Please.
Where do we go to next?
Great, can only get down so far.
How do we know R was a midpoint of segment QS?
Given.
So, we could say that QR and RS, or RS is congruent to QR.
How do we know that those two segments were congruent?
The midpoint split segment and congruent segments.
once we have all that,
Um,
look at number 2 and number 4. Notice anything in number 2 and number 4?
PQ is congruent to QRS, because they're both congruent to the same thing.
So what do you notice in 2 and 4? They both have what?
QR.
They both have QR. Well, if QR is the same as PQ and QR is the same as RS, what's that tell us about those two?
They're congruent.
So what am I gonna write?
PQ. Congruent.
What do we use there?
Same thing.
Substitution.
Substitution property. Did we have to switch this to the algebra form? No.
No, sir.
Boom, we're done.
That's what we're trying to prove?
Yeah.
Again, if this is on the test, how many points would this be worth?
10.
Yeah. What if someone does more or less, like steps,
It just depends on what those more or less steps are.
like some of them would count?
Some of them might, some of them might not. Some of them I might take points off for, some of them I might not take points off for, it depends on. Like on this one, we could have went through here and said, this segment plus this segment equals this whole thing. And then this segment plus this segment equals that whole thing.
And then those two are equals.
And those two are equal, and then we could have got to what we were trying to prove using segment addition. It'd been longer. This was the easiest way. How many points should you get
10.
11.
out of this whole thing here?
11. 5.
Everything except for the
It's
last
streaming
one.
11.
Maybe,
So 8.
maybe you missed that. I'm hoping, if you see that you have a midpoint, should you know that these two segments are congruent?
Yeah.
Yeah. I'm thinking that you should get at least 9 out of 10 points on this.
Funny guy.
Regardless, even if Josie says she doesn't like these two column proofs, even if she doesn't like them, should you be able to get that many points on this? Don't make them harder than they are. Next one. What do they tell us on this one?
Angle 1 is congruent to angle 3.
So mark your angles congruent. Those two angles are
Is there
congruent.
a name for those angles?
There is, but when we took this test, we hadn't covered that yet, so. If I remember, since, Mr. Laird there brought it up,
I forget what those are called.
anybody remember what those
It's in our
angles are
notes
called?
somewhere.
No.
That's true, they are acute, but if these two lines,
They're not on
if,
next to your.
if these two lines were parallel, we'd know that those two angles are congruent. They wouldn't even have to tell us this. They just tell us that the lines are parallel, and then we'd know that those two angles are congruent because they're what special kind of angles? Corresponding angles. Remember, you smash the two lines together. If you smash this line on top of this line, the ones that lay on top of each other are corresponding angles.
Couldn't you just say that, like,
Is
if
that
it was,
here?
if we learned this already, couldn't you just say 2 and 4 because they're corresponding?
Corresponding angles. So with what we know now,
It's like a
if
step.
these two lines were parallel, we'd have to say that the lines are parallel, and then we could just say angle 2 and angle 4 are congruent because they're corresponding angles. But they didn't tell us it, we didn't know it then, and they didn't tell us that the lines were parallel.
But if they're congruent, they have to be parallel,
Right. And that's going back the other way.
right? Never. Boom.
So what Michael said is we could even go farther than this and say if these two angles are congruent to each other, then what has to be true about these two lines?
They have to be parallel.
They have to be parallel. So they could have did something like this and put that as one of the given statements and prove that the two lines are parallel.
That's so
And we
cool.
could prove that they were parallel by going that extra step. But on this, since we didn't know all that yet, what do we know on here?
1 and 3.
1 and 3.
1 and 3 are congruent, we marked that, what
2
else?
and 4 are congruent.
I have to be careful.
1 and 2 are congruent.
1 and 2 are congruent. How come 1 and 2 are congruent?
Oh, okay.
They're vertical angles.
3 and 4 are congruent.
If 2 and 4 are congruent,
3 and 4,
or if 1 and 2 are congruent, what kind of mark am I gonna put on 2?
same thing.
So 1 mark, so what's that tell me about 2 and 3 now?
They're congruent.
They're congruent.
And 3 and 4 are congruent. 'Cause
3
they're
and,
vertical.
3 and 4 are congruent because they're vertical. And what kind of marks do I put on 4 then?
Same.
Same thing.
So everything.
What's that tell me about all 4 of these angles?
They're all congruent.
So what's that tell me about 2 and 4, which I'm trying to prove?
They're congruent.
They're congruent. So we should be able to go through and do this. Statement. Reason. What's our first statement gonna be?
Angle 1's congruent to angle 3.
How do we know that?
Yeah.
Make sure you're numbering your steps. Make sure you're using your symbols. That was all the given information. What did we say next?
That
That
1 and
1
2.
and 2 are congruent because they're vertical.
Angle 1's congruent to angle 2. So do I just write because vertical?
No, don't you write vert angles are congruent?
Vertical angles are congruent. Looking at 1 and 2, what do you notice from 1 and 2?
3 and 2.
If they're both the same as angle 1, then what has to be true about 3 and 2 here?
Angle 2 is congruent to angle 3.
Okay, so angle 2 is congruent to angle 3.
Wait, isn't there one that says like angles congruent, 2 congruent angles are congruent?
I don't know, did we have something like that?
Yeah.
It's like, what? It's less steps.
Maybe one misstep in. Well, how did we know 2 and 3 were congruent?
What? Substitution.
Substitution property. Where did we go to next? Are we finished?
Not quite.
3 and 4 were congruent.
So angle 3 is congruent to angle 4. How do we know that?
The vertical.
So what do I write?
Vertical angles are congruent.
Vertical angles are congruent. We finished?
No. Because then you have to say that angle 2 and angle 4 are congruent.
So look at what we have in 3, what we have in 4. Anybody notice anything?
They both equal angle 3.
They both have angle 3 in it, don't they? So these two angles are both equal to angle 3, then what's that tell us about those two angles?
Angle 2 is congruent to angle 4.
Angle 2 is congruent to angle 4.
Substitution.
Substitution property again. Are we finished?
Yeah.
Yes.
How many points would this be worth on test?
10.
Looking at it,
You should get them all.
you should probably get them all, but let's say you don't.
9.
No. Probably like
7.
Maybe 7, at least 1, 2.
6.
Should everybody know vertical angles by now?
yeah.
3, 4, 5, 6, 7. 7 out of 10 for sure.
Whoa, whoa.
We'll come back to that.
Is that today?
Yeah. Okay, test.
I was like, we have a test today?
Slope and y-intercept, find this on your notes there.
Oh, I forgot about this stuff. Y equals,
Well, the next plus b.
That's slope-intercept form. Now, don't get that confused, all right? That's slope-intercept form of a linear equation, y equals mx plus b. You might want to write that down somewhere, y equals mx plus b. What's the m stand for?
Just
That's your slope.
and the B is the Y
So
intercept.
b is the y-intercept. Might be a good thing to have in your notes right there somewhere. Refresh your memory.
Rise over one.
And slope is rise over run.
Mm-hmm.
It's easy.
Up 1 over 2.
Alright, and we'll write that over here. For slope. This is big M.
Little m.
Don't get this confused. Slope is little m. Rise over run. But it's also, you subtract the y's on top and subtract the x's on bottom. So on these, all we want to do on each of these graphs is we want to find the slope and the y-intercept of each. So we're going to find the slope, the m, and we're going to find the b for each one. Finding the b is easier. The b, the y-intercept, what's that asking you to find?
Where it goes over the y-axis.
Where it hits the y-axis at. Where does it look like this one hits the y-axis at?
Positive 1.
Positive 1, so just put a 1 there. How are we going to find the slope?
Go.
Don't you pick
Three
2
there.
points?
Pick 2 points. So maybe I pick this point and I just had that point, so I'll pick it.
But that one's not on the line.
It's supposed to be.
2/3, -2.
My line's a little off, it got moved a little bit somehow.
-2/3.
So how do I do it? What do I do?
2,
Up 2,
and then
3. Left 3.
left 3, so what's that tell us?
It's negative. It's negative.
Negative slope, negative 2 over 3. If we wanted to write an equation, could we write an equation for it now? It'd just be y equals negative 2/3 x plus 1. Next one, slope, y-intercept. What's our y-intercept this time?
10.
0.
1, 2, 3, 4, 5, 6. So it looks like 7 maybe.
Did you say
So maybe we better do what? Better find what first?
Slope.
Maybe we better find the slope, so let's pick a couple of points. Looks like that point looks pretty close to being right at the intersection, doesn't it?
And then
And up
one.
2.
No.
Or,
This
yeah,
one?
that one, yeah.
That one looks like it's really close, should be right there.
Slope's 3.
So what's the slope? Rise is how much?
3,
3, run,
that's 6.
And then kick
so it's 3 over 1, which is, you guys would tell me is just what? 3. Now, if the slope is up 3 over 1,
And can't you pick out a point?
up 3 over 1, and that looks like we're a little off there.
Wait, it needs to go up 2 more spots, because that's like
So-
really.
Good job.
So maybe that one wasn't on the line? Is that what you're saying?
Yeah.
It'd be about there instead, so instead of 3 over 1, what's it gonna be?
5.
5 over 1, which is just
2.
5. Oh, it was over 2, wasn't it? So 5 over 2,
That's 2.5. So 2.
so 2.5. Do we usually wanna change that to 2.5? Usually you wanna leave it as 5 over 2, right? If it's slope. So what's that telling us?
So the next point will be up 5 over 2.
Up 5 over 2,
Wow.
somewhere over in here. But what's gonna happen right here?
It's gonna hit
It's gonna hit the y-axis there. What point is that?
7.
Everybody agree with 7? Yes, yes, no, maybe?
1, 2, 3, 4, 5, 6. Maybe the next one up.
Yeah.
No, it's gonna be this one.
So 6.
6. So what's the y-intercept?
6.
6. So slope was 5 over 2, y-intercept was 6. Again, looking at this, you guys told me this, what kind of slope should this line have? A negative, because it's going downhill. What kind of slope should this one have?
Positive.
Is that what we had, was a positive? So make sure of that.
In neutrality.
Next one, slope, y-intercept.
Slope 0.
Slope 0, does everybody agree with that?
If intercept's 2.
Y-intercept is negative 2. How'd you know the slope was 0?
I was like, it's a straight lines.
Yeah.
All lines are straight.
It was.
You get it?
No, I don't.
It's horizontal.
It's a horizontal line. Write that down somewhere on your paper.
I was gonna say vertical, but that's.
Horizontal, alright? If it's a horizontal, what's your slope always gonna be?
0.
0. So if we have that here, something else you might wanna write on your notes somewhere, what if you had a vertical line? What would the slope be?
Wouldn't it?
Let's draw a vertical
10.
line in here.
1, right? It's 1.
What's the slope of that?
Same
It's
thing.
1, because it's 1 over 0.
It's 1 over 0, so you might wanna grab your calculator
That's
out.
0.
What's 1 divided by 0?
0.
Grab your calculators.
Oh, wait, no, that's,
1 divided by 0. You just told.
0. Wait, 2, 5.
Air.
Josie says air.
yeah, it's,
So what's that tell us about the slope of a vertical line?
Yeah.
You can't have it. It's undefined. Write that down somewhere, because you guys aren't gonna remember it, because you didn't remember it from last year. If lines are horizontal, slope is 0. If lines are vertical, then the slope is undefined. Two key things, nothing, with vertical and horizontal lines, nothing else you can do about them, you just have to have them memorized. Next thing, we want to graph these.
You need
we
a
have to
point in
make-
the middle.
You have to make lines first.
So, do we always want to just put our X and Y axes right in the middle?
No.
So if you do this every time, if you come on your graph, and first thing you do is draw your X and Y axes and you put them right in the middle, you're probably messing up. Alright? So look at your points and look at your slope and stuff and whatever it is that you're graphing, and decide, hey, do I need any more space in any of these certain areas? Well, this isn't too bad, but we do have an X that's 6, so that means we need to go which direction? 6.
Right.
To the right, 6. So probably, if we know we have to go to the right 6, we probably want to bring our y-axis over this way a little bit. Now with the x-axis, does it really matter with it?
Up to 3 from the bottom. I would think.
So maybe Josie's saying put it right here, is that all right? Will that work? Yeah. Now what are we gonna do? How are we gonna graph this line?
It's gonna go up 1.
What do we do to graph this point right here?
Rise overrun.
Now be careful now, and this is where a lot of you mess up, once you got into slope.
You gotta,
Go down 3.
This is your x, that's your y.
you gotta go right.
What's the x tell you to do?
Go right or left?
Go to the right 6. Remember, x tells you left or right. Y tells you what? Up or down. Don't get it confused, because with slope, you go up or down first, and then left or right. So how am I gonna graph the point 6, 1?
Go down negative 3.
Or what, 6?
Alright, 6, 1, 2, 3, 4, 5, 6,
Up 1.
and up 1, and put a point. That's our first point, that's the point that we're starting with.
And then
What's this slope tell us? First thing, if I got a slope that's a whole number, I should probably put what underneath it?
Overrun.
1. Then I have my rise and my run. So what's the negative 3 telling us to do?
Down
Go
the
down.
valley.
Down 3, and what's the 1 telling us to do? Right 1, and put a dot.
you could also go up.
Well, the bad thing is, I ran out of space going that direction, didn't I? So, let's go back to the original point. Instead of going down 3 and to the right 1, I could have went how?
Up 3 to the left.
Up 3 and to the left 1. Then up 3 to the left 1. What am I gonna do once I have all those points?
Draw a rough line.
Straight line. But that ain't straight line.
Draw, connect them all there, make our line. Next one. Where's my X and Y axis? Can they be in the middle?
Yeah.
Yeah, this one's not too bad, so you could put your X and Y close to the middle there if you wanted, wherever. How am I gonna graph that point?
Over 2 and down 4.
Which direction?
From the, yeah, right there, go to the right 2.
Right 2,
And then down.
put a dot. Right 2, down 4. What's the slope tell us to do this time?
Go up 1 into the left 2.
Up 1 and to the left 2?
Right. Right.
Up 1 to the right 2? Everybody agree with that? So up 1 to the right 2. Up 1 to the right 2. What happens when we run out of space going that direction?
Go down.
Down 1 to the left 2.
Down 1 to
Down 1 to the left 2.
make your line.
Draw in your line. Could we find the y-intercept? Where did this line cross the y-axis at?
-5.
-5. So if we know that our b is -5, could we write an equation for this line now?
Yeah.
Yeah.
Y equals
X
1/2 x
minus 5.
minus 5. That would be the equation for that line. Next one, where am I gonna draw my x and y?
Why are we going over this one?
Because we're gonna use it.
Okay. Seems like.
Where, where am I gonna draw my x and y?
In the corner. Might as well.
What?
So what do you mean in the corner?
Like just like the sides.
On the very side?
Yeah.
This side over here or this side?
The other side.
This side?
Yeah.
Where's my y? Or my x, sorry.
On the bottom line.
Is everybody alright with that?
So you're gonna make like, what is it, one of the quadrants?
Quadrant 1, is everybody alright with that? Is that gonna work?
Yeah.
Yes, no, maybe?
Yes.
What do we graph first?
0.
And.
Oh, over.
So what's over 9?
Yeah.
No.
No,
Over
up.
0.
Up. Up 0.
So we go left to right how much?
0.
And then
up 9.
1, 2, 3, 4, 5, 6, 7, 8, 9. What's special about that point right there?
It is the y-intercept.
So when we see something like this, that looks like that with our x being 0 and this number, that tells you the
Y-intercept.
y-intercept. Now what?
From that point, go over 2.
What's the slope again? It's rise over
run. Sorry.
run.
Yeah. So up 2 over 3.
Which way 3?
Right.
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 You in here?
Now what's gonna happen since we drew our x and y axes? Where do we drew them?
We're only gonna have one dot.
Is that really gonna work?
No.
Because if we messed up one of those two, what's gonna happen to our line?
It's gonna get whacked.
It's way off, alright? So we probably should have drawn our y and x axes maybe somewhere a little different.
Like the first one.
Maybe we should, right, maybe we should have put the y over in here somewhere so that we could have went both directions. We could just sorta estimate going up here. How much are we supposed to go up?
2.
Up 2, to the
And
right,
3.
3, so somewhere about in there. Everybody alright with that? Now, once we have 3 dots, then we're okay to draw our line. If you only have 2 dots, does that mean our line's correct?
Yeah.
No.
No,
How do you know?
you don't
Then you
know.
have-
That's the whole thing.
Alright.
You don't know if it's correct or not, because 2 dots are always gonna make a line. 3 dots, are they always gonna make a line?
Oh. You're always gonna make that exact line.
Alright, now, if we have 3 and they do make a line, then we did it, okay.
I forgot how to do this.
Could we write an equation for this line?
Oh, what is this?
Yes, no, maybe?
Yeah.
What's our m this time?
So it's X over 2 over 3 equals.
No, x
Nine.
plus 9.
So
X plus 9.
plus 9. Remember, the slope goes here, y-intercept goes
I was say that.
there.
I said no.
So that would be the equation for that line. I see Jacob back there messing with his calculator. Could he type this right here into his calculator and graph it? Yeah. All right, a little harder stuff, solving systems of equations. Write this on your notes there somewhere. Last year, you learned 3 different ways to solve systems of equations. Anybody remember?
What's factoring on
Substitution.
Substitution,
Graphing.
graphing,
Oh my god, I got it right. Elimination.
elimination. Now, with graphing, each of these equations, when there's no exponents, is going to form a line. So if we were to graph our 2 lines, and it ended up looking something like this, where's the solution going to be at?
Where it intersects.
Where the 2 lines intersect, all right? That's solving. Probably didn't like this method because it takes a lot to graph them, and it's real easy, as we seen as we were just graphing
The
those,
elimination's easy.
right? Elimination, and that's probably the one that you're going to use most of the time. The bad thing with elimination is they have to be in this form, which is called standard form, where all the x's and y's are on one side, and all the regular numbers are on the other side. Which, nice thing, what do we notice about all our equations here?
They're all like that.
They're all in standard form.
They're all like that.
Yeah.
Right. Substitution, most people don't like substitution. I use substitution more than I use any of the other methods. I like it the best. But that's just the way my mind works. Substitution, again, is you take out one thing and stick something else in its place, right? With substitution, what you'd have to do is, like, if I was gonna do it for this equation, I got x plus 2y equals 2. If I want to use substitution, then what I gotta do is get one of these variables all by itself on one side. Well, here it's not too hard to do. If I wanted to get the x variable by itself, I just subtract 2y and I end up with x equals 2 minus 2y. So anywhere that I see x, I could substitute in what? What do I know x equals?
2 times 2y.
2
minus 2.
minus 2y. So anywhere I see x, I could stick that in there. That's all substitution.
Interesting. Is an elimination where you like multiply it to get the right thing?
And that's what we're gonna do here. So with elimination, they gotta be in this form. This is the part that you wanna write down there on your notes. They gotta be in this form, and then we want to eliminate one of the variables. Well, to do that, we gotta get either the x's or the y's to be opposites of each other. Pick a variable, x or y, for this first one. Y. So if we pick y, what do you notice about here and here? What's the coefficients for this y?
2.
2. What's the coefficient for this y?
Negative 1.
-1. You might want to write that 1 in there if you don't remember that that's a 1 there on that coefficient for that y. How are you going to get those two to be opposites of each other?
Multiply the bottom one by 2.
So put parentheses around this bottom one, and we're going to multiply that whole thing by 2. Everybody sort of remembering this? What's 2 times 2x?
4x.
You got to make sure you multiply this 2 times that whole equation. What's 2 times negative 1y?
Negative 3y.
And then what's 2 times 4?
8.
8.
And then you can like subtract, right?
Now what happens here, once you have that, this equation, is sort of gone. We're not using it anymore. And now what we're gonna do is take these two equations and add them straight down. What's x and 4x give us?
5x.
Everybody agree with that? Yes, no, maybe?
Yeah.
What's 2y and negative 2y give us?
Nothing.
So they just cancel out. What's 2 and 8 give us?
10.
What's nice about this new equation that we have?
We can solve it.
Why?
Because there's only one.
It's only got one variable. It doesn't have both x and y in it. It's just got one x in it. How do we solve it?
5 by 5 on this side.
What's x equal?
2.
That's part of our answer.
If it's got y.
Remember, when we're doing this, we're trying to find a point where these two lines intersect at. So you got an x coordinate and you have a y coordinate. So we still have to find the y. How are we going to find the y?
Now we know x, we can put 2 for x.
All right, so back up here, in any of these equations that we have, we can stick 2 in their place. So pick one. Which one do you want to
The
put in?
first one.
The first one. So if I put 2 in place of x there, I got 2 plus 2y equals 2. How you going to solve that?
Minus
Subtract
2.
2.
Subtract 2 on both sides. 2y
And that's.
equals 0.
So y 0.
Divide both sides by 2, so you end up with y equals 0. And y equals 0. Those are our two answers. When we're actually doing these, the way we should write our answer, because what were we looking for again? Where the two lines intersected. So we should write it as a point. So our answer should actually be written like this. What comes first?
X.
So what is x?
2.
2. What was the y?
0.
That's our answer. That point, 2 zeros, where the two lines intersect at. Can we do the second one? I'm running out of space here. Can we do it a lot simpler maybe?
Yeah.
Or a lot quicker? X or y, which one do you want to get rid of?
Y.
The y? So what do you got to do to the y's to get them to
Divide
be
the top
opposites?
one by 2. Or multiply.
Multiply the top one by
2.
2. So multiply the top one there by 2. What's that give us?
Wait, it has to be -2.
Oh, it has to be a negative 2. Does everybody agree with that?
Yeah.
What's negative 2 times x give you?
Negative 2x.
Negative 2x. What's negative 2 times 2y give you?
Negative 4.
No, wait, negative, 8x.
Top one.
Oh,
Negative 4y. What's negative 2 times 2 give you?
Negative 4.
Negative 4.
So does that mean everything works?
I don't know what happens here.
Everything cancels?
So that's cancels out, that cancels out, that cancels out, and we end up with 0 equals 0.
Doesn't that mean everything works usually in algebra?
So what that means is any point
So does that mean these lines are on top of each
will
other?
work.
So does that mean
So if we're looking at it, what's that telling us about the two lines?
They're on top.
They're on
of each
top
other.
of each
They're on top of, they're the same line, they're on top of each other. All right? So if I pick this point, is that where they intersect at? If I pick this point, do they intersect there?
Yeah.
So any point would work. So if it comes out that way, that's the answer. Everything is a solution. Next one. What happens on this one?
Same thing.
Same thing? Everybody agree with that?
No.
Pick a variable.
Negative.
Pick a variable, x or y.
X.
X. What do you gotta do to the x's to get them to be
Oh,
opposites?
this one's nothing works. Oh, negative 1.
Multiply top or bottom by negative 1? Bottom.
Negative
If I multiply it by negative 1, what's negative 1 times x? Negative 1 times 2y.
Negative 2y.
Negative 1 times negative 2.
equals 2.
This equation's sort of gone now. We add those straight down, what do we come up with?
0 equals 4.
0 equals 4. Everybody agree with Kellen on that?
So they don't intersect. So they're parallel.
So what's that telling us about those two?
They're parallel.
They never intersect. So are parallel. Kellen, you starting to see where this fits
Yeah.
into what we're doing?
This is gonna be horrible.
So they never intersect, so they're parallel. So what's the solution? Where they intersect at?
They don't.
They don't, so there
Is no intersection.
no solution. They don't intersect each other, so there is no solution of where the two lines intersect. Next one, pick a variable.
3.
What?
What?
X or Y do not agree.
2. Y.
X.
You still said
Which one?
X.
X?
2.
What do we want to do to the x's, get them to be opposites?
Divide our on the bottom one by negative.
What's negative 1 times x give us?
Negative
Negative 1 times negative y?
Y.
Positive y.
Yeah.
Negative 1 times negative 4?
4.
This equation's sort of gone. We add them straight down. X and negative x give you what?
3y.
Okay, you just have 3y there. 2 and 4,
6.
6. So are these two lines parallel to each other again? No. They actually intersect because we can find the solution for this one, right? Are they the same line?
No.
Divide both sides by 3, what's y end up being?
2.
So if I'm writing my point down here as my answer, where's that 2 go?
The second one.
Put a 2 there. Once I know y is 2, what am I going to do?
Now you know y is 9 punch 2 into y.
Put 2 in for one of them. I'm going to put it into, is it all right, put it in this one? So you got negative x plus 2 equals 4. What do you do to solve that?
Subtract 2.
Negative x equals,
2.
is that our answer, 2?
No. It's negative 2 because you got divided by negative 1.
So divide both sides by negative 1. So x equals negative 2. Where are these two lines cross at then?
Negative 2.
Negative 2, 2.
Negative 2, 2.
You're wearing a what?
Didn't I say last time I was going to set one of you guys out in the hallway? It's getting ready to happen.
There was a whole break in between the. I
Did
do
you
know
hear what I
that.
said? Did I say that he did anything wrong right now? I was just reminding both of you that I said last time that one of you's gonna sit in the hallway.
But if we're sitting out in the hallway, why 4?
I didn't say that you did anything yet, did I? I just said that last time I said that I was gonna set you out in the hallway. Now, my reason's gonna be here in a minute, cause I'm having this argument with you. Notes from last time, get out your notes from last time. We're gonna go back over some of these really, really quick.
So those are notes that we just took like that.
By the time you get them out, I should be about to where I need to be.
I'm stacking already.
What gets out of college?
It's so scary every time I look at it back. That? Is that the one? No. Oh wait, yeah, that's.
What are you wanting to do?
It was such an
And then they show you.
You were on the cover.
It's a lot easier for you in a second than it is for me. Go to right here.
Right where? Is it 3-7? Is that what it's from?
That's it.
Got it.
Remember, with this, what's these extra arrows tell us about those two lines? Parallel. Gotta know this. What's that third line called?
The trans.
It's on your notes there somewhere if you're looking at it.
Transversal.
The transversal. Alright? So we have our two parallel lines are transversal. How many angles are formed? 8 angles. No matter what, the 8 angles are formed. If they're parallel, then we know these special rules. If the lines are parallel, then corresponding angles have to be congruent. If the lines are parallel, alternate interior angles have to be congruent. If the lines are parallel, alternate exterior angles have to be congruent. The one oddball pair is the consecutive interior angles. They're not congruent, they are what to each other?
Supplementary.
Supplementary. So looking at that, this is going to decide, everybody better be paying attention. This is going to, I think we're going to take that vocab test here in a few minutes. All right? But just in case, Branson, I'm trying to help you out because I think you don't want to take it, do you? So I'm trying to help you out. If everybody's paying attention and answering and thinking right here, maybe we won't take it right now. Name me a pair of corresponding angles in the picture before Kellen yells anything out. Think about it for a minute. Go ahead, Riley.
1 and 6.
1 and 6. Everybody agree with that?
Mm-hmm.
Is that the
Yeah.
only pair?
No. 2 and 5.
2 and 5.
3 and 7.
4.
What do you do with the lines to figure out the corresponding angles?
Smash.
Smash them together. Don't fold it. Smash them together. What do we know about angle 1 and angle 6 in that picture?
Corresponding.
They're corresponding and they have to be what to each other? Congruent. So if I told you angle 1 was 100 degrees, what's angle 6?
100 degrees.
100 degrees. Same idea on this next one. Name me a pair of alternate interior angles.
4 and 7.
3
Think,
and
look
5.
at it real closely, don't yell it out. Think. Alternate interior angles. Anybody remember what did we say about alternate interior angles last time?
Is it like
They make a Z.
They make a Z.
2, 3?
So they make a Z together. Go ahead, Josie.
4 and 5.
4 and 5. Do they make a Z together?
Yes.
3 and 6.
Yeah.
3 and 6 are the other pair, right?
Yeah.
Make sure you can pick them out. All right? I'm going to steal your lunch from you if you don't do that.
And I drink the Capri Sun.
You
Please.
shouldn't have been eating the other stuff and you wouldn't be thirsty right now.
Yeah, that's a fair statement. May I drink Capri Sun?
Don't ever ask me again. You don't think you're getting away with it ever again. What do we know about alternate interior angles?
It makes a Z.
They make a Z, that's true. What else? What's our theorem tell us?
The lines are clear and everything.
They have to be
Bigger.
congruent to each other. Alternate exterior angles. Stop, think, before you yell out anything, look at them and think. Alternate exterior angles. Which ones are exterior angles first? Let's go with that.
1, 2, 8.
1, 2, 8, and 7. All right, Ethan, go ahead.
1 and 7.
1 and 7. Does everybody agree with 1 and 7?
Yeah.
So those are alternate exterior angles.
2 and 8.
And 2 and 8's the other pair. If these two lines are parallel, what do we know about angle 1 and angle 7?
They're the same.
They have to be the same. The last one, consecutive interior angles. We called them, or I called them, if you don't want to do it,
Roommates.
that's up to you. I called them roommates. They're the only angles that don't have a line between them. Alright? So look at this and name me a pair of consecutive interior angles.
3 and 4.
4 and 6.
3 and 5, 4 and 6. Everybody agree with all that? What do we know about angle 3 and angle 5?
They
Be
add
careful.
up to
They're
180.
different.
They add up to 180.
Oh.
Again, on your notes, if you didn't do this last time, you might want to put a big asterisk out here next to that, because that's the one that's different than the other three. they add up to 180 instead of being congruent. Those are the ones that add up to 180. What do you know about, again, stop and think before you yell anything out. What do you know about angle 6 and angle 7? They're vertical angles, so they have to be congruent. Name me another pair of vertical angles in this picture. 1 and 3. 5 and 8. Should you be able to pick out all those vertical angles and use them in your picture also?
Yes.
Yeah. Name me, or what do you know about angle 6 and angle 8?
They're supplementary.
Why? What kind of angles are they?
Linear pair.
They're a linear pair, so they have to add up to 180. Name me another linear pair in this picture. 2 and 3. Another one.
5 and 7.
5 and 7. Another one.
1 and 4.
1 and 4. Another one.
1 and 2.
1 and 2. So on, so on, so on. All of that information just from knowing that what's true about these two lines. What was true about these two lines?
They're vertical.
What's this?
Parallel.
What's this line called? Transversal. Ignore this. We're going to do this. Back on your notes that we just got done taking, I want you to draw this picture that I'm drawing. I'll be out of the way in 1 second. Wasn't there a little space on the back of that last page?
Yeah.
Like right, sort of a big space right there. Take a minute or two, draw that. Oh, I see what you guys are doing. You guys were looking for this, weren't you? No, you don't want that.
You flip-flop 16 and 15.
Does that bother you?
Yes.
Good.
I didn't even notice that.
Yeah, me neither.
Does that bother
Shouldn't
you?
make any difference, should it? The other thing I want you to write down. Oops. See if I can use that now. Measure of angle 4 is 102 degrees. And the measure of angle 16 is 73 degrees. Write that on your paper there somewhere. How many of you are writing in pen? Good. Go through and find all the angles.
Oh, yeah, you can't find all of
Yeah,
them.
you can.
Every single one?
Every single one. I'd write them in there lightly, because you're probably going to be wrong.
My bad.
Just take a minute or two. try to find each angle. You can write them in right in the angles, so like instead of, you can, whatever you think angle 1 is, you can write it right in that area there where angle 1 is. Just don't write real dark because you're probably going to be erasing a lot. I can say this over and over and over again, but if you're not actually trying anything right now, we're about to that point where Ebersole's about tired of begging people to try. I want you to try to find each angle here, just so that we can show something, all right? We may have to take that vocab test day, because you guys aren't gonna be here Thursday. A whole bunch of you. So we should take it today, shouldn't we?
I do that class with 2 people, right?
You should do that anyway. What's that got to do with this?
Some people were. It's gonna be me, Leland. Right?
I mean, do you think you
Yeah.
get the test done in 7 minutes?
It'd be 3
Huh?
of us.
Do you think we can get the test done in 7 minutes?
Yeah. Alright, so on this. Angle 1. What was angle 1?
78.
78. Everybody agree with that?
Yeah.
Yes, no, maybe?
Yes.
Angle 2.
102.
102. Angle 3.
78.
78. Angle 4 we already know. Angle 5.
107.
107. Everybody agree with that?
Yeah.
Angle 6.
73.
73. Angle 7.
73.
Everybody agree with that? Now some of you, I know that some of you are messing this up, alright? When you look at this, you've got to be really, really careful. What 2 lines are parallel in this picture?
The A and B.
A and B. And I'm telling you that at some point, even the ones of you who are very intelligent, you're probably going to mess this up if you don't do what I'm telling you to do right at this moment. Look at just the 2 parallel lines and pick one transversal. Which 2 lines are transversals in this picture?
D and C. D and C.
D and C, right? So pick one of them. Which one do we want to start with? C. If we start with C, what do we know about all of these angles and all of these angles? Now, they're not all exactly the same, but
They're similar.
I understand what you guys are trying to say. You got 2 numbers, and they're all going to be one of those 2 numbers, right? So those 2 sets are going to go together. Now, maybe on your paper, you can do it something like this, where you can just cover up one or the other with your finger, your hand, or something, so you're not looking at it. But I guarantee the whole bunch of you are going to go look at these angles, and we know angle 4 is 102 degrees. And then you're going to try to jump down here and say angle 7 is how much?
102.
102. Is that true?
No.
That doesn't work. You got to make sure that you separate them off. So if you want to deal with these angles down here, what transversal do we need to use?
B. Wait, which one's the bottom one?
Bottom ones.
D.
D. I didn't hear what you said. So we use D as our transversal then. And then we go with that, and we know angle 16 here is 73. So now let's just look at that. If we just look at the top, tell me angle you know, so we can write them all in.
16.
Just the top.
Oh. 4. So 2 is 102.
So write that down. What else?
10 is 102.
Everybody agree with that?
11 is 102.
and then you do that, divide it.
78 is not, 1 is 78.
180.
With
Minus
angle 1 is what?
78.
78.
Give me another one.
78 is
Three.
3, 9, and 12.
Good job.
Thank you.
Mine was
So
the
write
same.
all those in.
No,
Now, can we jump from here to here and say that
No.
angle 15 is 78?
No.
Doesn't work. But down here, we do know this is 73. Cover this up. Give me an angle that you know.
14.
14 is how much?
73.
Give me another one.
7 and 6.
It's how much?
73.
Sorry, I got right with my arm in the way. What else?
180 minus
13 and 15 are 107.
Everybody agree with 107?
Yes.
What else?
5 and 8 are 107.
Whoa! You've got to make sure, and if you look at the packet, if I'm looking at the packet, when you get to the back side of it, what do you notice about some of these problems? Do they get a little confusing?
Just a hair.
So you're probably going to have to split stuff off this way, otherwise you're going to get confused. All right? So your assignment, the packet. Those of you who will not be here Thursday, make sure you check your email to see what we do and come and talk to me.
Phone's going up.
Alright, so